Hello, good evening, guys. Today's topic of discussion is 802.11 scanning. So, the contents are like this. First of all, we will look what is scanning and what is its requirement, why it's required. Second topic is what are the types of scanning. Then, what are the difference between the different types of scanning. So, during scanning, what are the channels basically we are scanning? How does scanning work? Then probe request frame, response frame, acknowledge frame, all these things we are going to discuss in today's topic. So the first topic is what is scanning and why it's required. See, basically scanning means before joining in any kind of network, the first client or the station, which for example we can call it as a mobile station, it has to find out first. That is the main requirement. Then only it can join to the network. If you look at in the wired world, just plugging the cable into the jack will find the network. But in the case of wireless, this requires identification of the compatible network before joining process. So this identification process of the network or discovering the network is referred as scanning. Why we do scanning is, the reason for client scanning is to determine a suitable AP to which the client may need to connect or roam currently or in the future. So this is the reason why we do scanning. So coming to the types of scanning. Broadly, this scanning is divided into two parts. The first one is called active scanning and the second one is called passive scanning. If you look at into the active scanning part, what happens here? The client, it has to transmit the radio as a probe request, and in the response it has to listen a probe response from an AP. For example, we will take an example of a mobile client. So whenever we will enable the Wi-Fi in that, it will send a probe request, and in return it's going to get the probe response. In the opposite case of active scan, passive scan is there. So in the passive scan, what will happen? Instead of sending a probe request, the client radio will listen on each channel for beacons which send periodically from an AP. So this is the basic difference. In the active scan, it has to send actively, and in the passive scan it has to listen. That is the first difference. Second difference, normally passive scan takes more time, since the client must listen and wait for beacon, whereas in the active scanning it has to send the probe to find the AP. Okay. So basically the summary of this second statement is, in the passive scan generally takes more time. If you look at the third thing, in the passive scan, the client does not wait. If the client does not wait long enough on a particular channel, then the client may miss the AP beacon. So this is, you can say, one of the main drawback of passive scan. Coming to the main difference between active and passive scanning. By default, radio performs both the types of scanning. all the channels allowed by the country of operation. Whatever the particular country is providing, it will do both kind of scanning. By default, it is enabled. So channels that are not authorized for unlicensed use and channels that require radar detection with the DFS, that is dynamic frequency selection, are excluded from the active scanning. Obviously, whatever channels are not supported or what are the channels coming on the DFS, that will not fall under active scanning. But during passive scanning, the radio listens for beacons and probe responses. So if you use only the passive mode, the radio scans once per second. Just remember, in case of active scanning or passive scanning, that doesn't matter. The radio scans once per second. But during active scan, the radio sends probe request. But instead of passive scanning, the radio listens for beacons on each channel. Passive scans are always enabled and cannot be disabled. This is as designed. We can't disable the passive scanning, but active scans are enabled by default, but can be disabled in a radio file as well. This is possible. Then coming to which channels are scanned. So this radio frequency scanning can be performed on a variety of different sets of channel ranges or frequencies. So coming to this, the scan can be performed in the radio profile to scan either operating channels, regulatory channels, or all channels. So let's look one by one. What do you mean by operating channels? The current channel which is scanned and audited, meaning suppose AP is configured to channel number 6. So this is the operating channel right now. Okay, so that is nothing but the current channel. If you look at the regulatory channel, so these regulatory channels are scanned and audited. So if the radio is configured to, for example, 802.11 2.4 gigahertz, that is, you can say BGN, the most commonly used channels are 1, 6 and 11, which are audited more frequently. These are called nothing but regulatory channels. All channels, as the name indicates, it has to scan in all the channels. Okay. How does this scanning work? If you look at the active scan algorithm, this is very much sensitive to the high priority data, high priority traffic, or you can say heavy traffic. So high priority means the voice will come in the number 1, then the video will come into picture. So basically active scan scans for 30 milliseconds once every second. Okay, unless either of the following conditions are true. Okay. The conditions are like this. If a high priority traffic, that is voice or video, is present at 64 kbps or higher, in this case this active scan scans for 30 milliseconds every 60 seconds. Don't get confused. In the earlier case we told that the active scan will happen in every second for 30 milliseconds only. But if the high priority traffic is present at 64 kbps or higher, it has to do scanning for 30 milliseconds in every 60 seconds. Coming to the second point, if the heavy traffic is present at 4 Mbps or higher, in this case active scan will happen 30 milliseconds in every 5 seconds. So this is a little bit delay because there is high priority traffic. We can't avoid it. Coming to probe request and response. What do you mean by probe request and response? See, if you look at this, whole scanning procedure is happening through this probe request and response plan. if you take a sniffer, we are going to observe these two packets, probe request and set response. If I'm in station and I'm doing scanning, means I'm sending a probe request, and in the return I'm getting a response, probe response. So let's look one by one. In the active scanning, stations will go through each channel in turn. For example, we think that it's configured in 2.4 gigahertz. So what it will do, it will start in the channel number 1 for 1 second, and in each 1 second it will wait for 30, it will scan for 30 milliseconds. Okay, so like that it will change the channels from 1, then 2, then 3, then 4, like that it will go. But instead of passively listening to the signals on that frequency, stations send a probe request. That is a management frame asking what network is available on that channel. So probe requests are sent to the broadcast destination address. How you will come to know there is a broadcast destination address? Because initially I don't know anybody. I just enabled my Wi-Fi in my device. So initially what it will do, it will send a broadcast probe request. If you look at the sniffer, this destination address will be seen as like this: FF, 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 FF. So by looking at this, you will come to know that this is a broadcast destination address. So once the probe sent, station starts a probe timer. That is nothing but a countdown, that is a timer, and wait for the answers. So at the end of the timer, station processes the answer it has received. If no answers received, station moves to the next channel and repeats the discovery process. So it will continue till it scans in the every channel. Okay. Okay. See, this probe request broadly classified into two parts. Okay. So we'll look at the first one. The SSID value can also be set to 0. That is, SSID field will present, but it will look like empty. If you look at the SSID length, that will be 0. Why it will be 0? Because that SSID field is itself empty. So when the SSID field is empty, that is called wildcard SSID. Okay. SSID is nothing but the name of AP. Okay. Service Set Identifier. Okay. To the wildcard SSID, we also call it as null probe request. Okay. Means SSID field is empty. So this is the first type of probe request. Second type, station sending a probe request may specify the SSID they looking. So if I'm looking for a particular thing, then the SSID field will be filled with the respect to SSID. That is called directed probe request. Then only in the IBSS station or AP support that SSID will answer. Okay. Now I'm going to tell you, during the scan, probe request and response happens. Okay. So this probe request is broadly classified into two parts. First one is wildcard SSID or null probe request, and the second one is called directed probe request. So when the wildcard SSID will happen, when the directed probe request will happen, just try to understand. I am taking the example of the mobile. Just what I did, I enabled my Wi-Fi in my mobile. Initially what will happen, when I just switched on my Wi-Fi in my mobile, it will list down what are the APs present in my surrounding. Let's take an example of 5 APs present in my surrounding. Number 1, 2, 3, 4, 5. Okay. So in that case, what will happen? Station will send a wildcard SSID. Means the SSID field will be blank. Okay. Then in return it will get the response. with the particular from the particular APs. In this case, from 5 APs, it got the response. Okay. If I want to connect with a particular AP, let's say AP number 2, I have to tap on that. Okay. That time it will send a directed probe request. So that directed probe request is nothing but that SSID field will be completely filled with the name of the SSID, that is AP2. Okay. So in this way, initially wildcard SSID will be sent from the station to the AP, then the directed probe request. Don't get confused with this. Okay. So if you look at another angle, wildcard SSID is nothing but a broadcast packet, whereas directed probe request is a unicast packet. I hope it's clear to you. So basically, a probe request frame sent by the client, which is a management type with the subtype value as 4. It's better to remember, better to understand, because this is a management frame and its subtype value is 4. So suppose as you can see, the client is sending at the 6 Mbps, that is the lowest supported rate by the client. We'll see in the next slide. So address fields are set like below. See, address field 1, that is the receiver address, which is nothing but the destination address. That is a broadcast one, that is FF, 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 FF. Address field 2. Address field 2 is nothing but the transmitter address, that is the source address from where it's initiating. Then the address field 3, BSS ID, that is also broadcast one. So if you'll ask me what is BSS ID, that is nothing but the AP's MAC address. Okay. Then we will see in the probe request frame. This SSID field set to open, indicating it is a directed probe request, because the SSID field contains the data as open. This probe request frame contains all kind of informations that client supports. For example, what are the supported rates, what is its capabilities, ST capability, VST capability, extended capability, all these things it will list down. So if you look at the SNF form, here it's showing what is the data rate it's supporting, 6.0 Mbps. That's what it's highlighted over here. If you look at the MAC header, it's showing that it's a probe request frame. Okay, this is the subtype. Then this destination is FFFF, that is the broadcast one, and the SSID is open. So it means that this is a directed probe request. Probe response. So now we are going to look at this probe response will come from the AP to the station. Okay, and this will send on 24 Mbps. Why this will send on 24 Mbps? Because what of the sniffer capture taken, that AP supports minimum 24 Mbps. AP does not support any rate below that. That is the lowest common rate supported by both station and AP. Okay, in this example. So DA, destination field, is nothing but the station, because it's coming from the AP, which is the probe request was sent. So destination address is station, source is AP, and the A3, that is address 3, is nothing but the BSS ID. Okay, so it has lots of other fields to describe the BSS, and it is a very similar to a beacon frame field. This probe response, if you look at it, this is very much similar to the beacon field, beacon frame. So this is a snapshot of that one. This is the probe response frame, which is coming from AP to station, and it supports minimum of 24 Mbps. This is the destination address. Destination address is nothing but the station's address. Okay, source address is AP's address and the BSS ID is AP's MAC address. Okay, and here you can look at it. SSID is filled as open, that is the name of the AP, and its length is 4. Okay, here it's showing what are the supported rates, 1, 4, like this. And let's move to the next slide. Here also you will see. So as I told you in the previous slide that probe response and beacon are the two frames. They are very much similar to each other, but there is some noticeable differences are there. If you look into that, the beacon frame contains a 10 bit, okay, but this 10 bit is not present in the probe response. The beacon frame is a broadcast packet, whereas probe response is a unicast packet. Okay. So the beacon frame contains all the information element, whereas the probe response contains the requested information elements that may have been requested by the probing station. Whatever the requested things came in the probe request frame, only to respond that particular frames, the probe response will contain that kind of information elements. This is a snapshot of containing from the previous slide. This is the country code, this is the QBSS, all this information is showing SD capability, SD information, whatever we are going to see here. Okay. Well, let's move to the next slide. This is the acknowledgement frame. So when it will occur, probe request sent from the station to AP, then the probe response came from AP to station. In turn, station has to acknowledge the same, that I got the probe response frame. So that is nothing called acknowledgement frame. So once the probe response is received by the station, it has to act to the AP. So this frame sent on lowest common rate, which is 24 Mbps in this case. Why this is 24 Mbps? Why not this is 6 Mbps as we discussed earlier? Because as agreed, station told that minimum supported rate by me is 6 Mbps, but station AP told that mine is minimum 24. So station has to agree on that point. So that's the reason station is responding that I am also supporting the 24 Mbps. Okay. So this is the sniffer capture. This is the data rate of 24 Mbps, and this is the acknowledgement frame. This is the type is control. Okay. So receiver is nothing but this one, AP. Okay. So that's all from my side in today's topic. Thanks a lot for watching this presentation. So if you like this video, this presentation, please do like, subscribe, comment, and click on the bell button. Don't forget to share with your friends. Thank you. Thanks a lot. Bye bye.